Hello everyone and welcome back to the channel. I'm so happy to see you here today. If you're new to this channel, please take a moment to subscribe. Click that subscribe button and hit the notification bell so you do not miss any of our upcoming lessons. If you find this video helpful, please give it a like. It really helps us to reach more students who need this kind of support. Also, I want to hear from you if you have any problems or topics you're struggling with. Please comment down below. I read every single comment. And for those of you who have personal questions or need one-on-one help, I will put my WhatsApp line below the video in the description box. Feel free to message me there. I am here to help you succeed. Today we are going to continue our journey into calculus. This is part 2, and we are going to talk about advanced differentiation. This lesson is suitable for SHS 2 and SHS 3 students, especially those preparing for further mathematics. Now, I know that when you hear the words chain rule or implicit differentiation, you might feel very nervous. Many students find this topic challenging because it introduces new rules and concepts, but I want you to relax. We are going to take this very slowly. We are not going to rush. We will break everything down into small, easy pieces. By the end of this video, you will understand exactly how to handle these problems. We have about 3 periods worth of content here, which is 120 minutes, so we have plenty of time to explore this deeply. I want this narration to be about 35 to 40 minutes long so that you have enough time to digest every single step. So grab your notebook, get your pen ready, and let us begin. Let us look at what we want to achieve by the end of this lesson. These are our learning objectives. By the time we finish, you should be able to differentiate trigonometric functions like sine, cosine, and tangent. You will learn how to apply the chain rule to differentiate composite functions. You will learn how to perform implicit differentiation on equations where y is not isolated. You will learn how to calculate higher derivatives like the second and third derivatives. You will learn how to combine rules like chain, product, and quotient to solve complex differentiation problems. And finally, you will learn about the physical significance of the second derivative, which is acceleration. That is a lot, but we will take it one piece at a time. Let us start with section 2, differentiation of trigonometric functions. When we differentiate trigonometric functions, there is one very important rule. Angles must be in radians. If you use degrees, the formulas will not work correctly. So always check your calculator mode or assume radians in calculus. Here are the standard derivatives you need to memorize. If y equals sine x, then dy dx equals cosine x. If y equals cosine x, then dy dx equals negative sine x. If y equals tangent x, then dy dx equals secant squared x. I need to give you a critical warning. Look at the derivative of cosine x. It is negative sine x. Do not forget that negative sign. It is the most common mistake students make. Sine becomes cosine, cosine becomes negative sine, tangent becomes secant squared. Let us look at example 1. Basic trig differentiate 10. Differentiate the following with respect to x. Number 1, y equals 3 sine x. The 3 is just a constant multiplier, it stays. The derivative of sine ax is cosine x, so dy dx equals 3 cosine x. Number 2, y equals cosine x minus 2 tangent x. We differentiate each term separately. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The 2 stays. So dy dx equals negative sine x minus 2 secant squared x. Remember the negative sign from the cosine. Number 3, y equals 5. 5 is a constant number. It has no x. The derivative of any constant is 0. So dy dx equals 0. Please write these down. These are the building blocks for harder questions. Now let us move to section 3, the chain rule. What is the chain rule? The chain rule is used for composite functions. This means a function inside another function. For example, y equals open bracket 3x plus 1 close bracket to the power of 5. Or y equals sine of open bracket 2x close bracket. You cannot just use the power rule directly because there's something inside the bracket. The formula is dy dx equals dy du times du dx. This sounds complicated, but here is the simplified rule. We call it the outside-inside rule. Step 1. Differentiate the outside function. Keep the inside the same. Step 2. Multiply by the derivative of the inside function. Think of it like peeling an onion. You do the outside layer first, then the inside layer. Let us look at example 2. Polynomial composite. Differentiate y equals open bracket 2x squared plus 3 close bracket to the power of 4. Step 1. Identify inside and outside. The inside function, let us call it u, is 2x squared plus 3. The outside function is u to the power of 4. Step 2. Differentiate outside. The derivative of u to the power of 4 is 4u to the power of 3. So we write 4 times open bracket 2x squared plus 3 close bracket to the power of 3. Notice we kept the inside the same. For now, step 3. Differentiate inside. The inside is 2x squared plus 3. The derivative of 2x squared is 4x. The derivative of 3 is 0. So the derivative of the inside is 4x. Step 4. Multiply. This is the chain rule. We multiply the outside derivative by the inside derivative. When we put door times open bracket 2x squared plus 3 close bracket to the power of 3 times 4x. We can simplify this. 4 times 4x is 16x. So dy dx equals 16x times open bracket 2x squared plus 3 close bracket to the power of 3. Answer: dy dx equals 16x open bracket 2x squared plus 3 close bracket to the power of 3. See outside first, then inside. Let us look at example 3. Trigonometric composite. Differentiate y equals sine of open bracket 5x close bracket. Step 1. Outside is sine, inside is 5x. Step 2. Derivative of outside. The derivative of sine is cosine. So we write cosine of open bracket 5x close bracket. Be inside the same. Step 3. Derivative of inside. The derivative of 5x is 5. Step 4. Multiply. Dy dx equals 5 cosine of open bracket 5x close bracket. Answer: dy dx equals 5 cosine 5x. Do not forget to multiply by the derivative of the inside. Let us look at example 4. Power of trig function. Differentiate y equals cosine cubed x. This looks tricky, but cosine cubed x means open bracket cosine x close bracket to the power of 3. So the outside is power of 3. The inside is cosine x. Step 1. Outside is open bracket ... close bracket to the power of 3. Inside is cosine x. Step 2. Differentiate outside. Bring down the 3. Reduce power by 1. So 3 times open bracket cosine x close bracket squared, which is 3 cosine squared x. Step 3. Differentiate inside. The inside is cosine x. The derivative of cosine x is negative sine x. Remember the negative sign. Step 4. Multiply. Did y dx ons equals 3 cosine squared x times negative sine x. We can write this as negative 3 cosine squared x sine x. Answer: dy dx equals negative 3 cosine squared x sine x. Please write that down. Notice how we had to use the chain rule twice here. Once for the power, once for the cosine. Now let us move to section 4. Implicit differentiation. What is implicit differentiation? Sometimes that cannot be easily made the subject of the formula. For example, x squared plus y squared equals 25. You could solve for y. but it would involve square roots and plus minus signs. It is messy. Instead, we differentiate term by term with respect to x. Here is the key rule. When differentiating a term containing y, multiply by dy dx. Why? Because y is a function of x, so we must use the chain rule on y. For example, the derivative of y squared is 2y times dy dx. The derivative of y is 1 times dy dx. But for x terms, we do not need dy dx. The derivative of x squared is just 2x. Let us look at example 5. Basic implicit differentiation. Find dy dx for x squared plus y squared equals 25. Step 1. Differentiate each term with respect to x. First term, x squared. The derivative is 2x. Second term, ua squared. The derivative is 2i times dy dx. Remember the dy dx. Third term, 25. This is a constant. The derivative is 0. Step 2, write the equation. 2x plus 2y times dy dx equals 0. Step 3, make dy dx the subject. We want dy dx alone. Subtract 2x from both sides. 2y times dy dx equals negative 2x. Divide by 2y. dy dx equals negative 2x over 2y. The 2's cancel out, so dy dx equals negative x over y. Answer, dy dx equals negative x over y. See how we did not need to solve for y first. That is the power of implicit differentiation. Let us look at example 6. Implicit with product rule. Find dy dx for x, y equals 10. Here we have x times y. This is a product. So we need the product rule and implicit differentiation. Step 1. Apply product rule to x, y. Let u equals x. Let v equals y. The derivative of uv is u times dvd. X plus v times du dx. U is x. The v dx is dy dx. V is y. Du dx is 1 derivative of x. So the derivative of x, y, u is x times dy dx plus y times 1, which is x dy dx plus y. Step 2. Differentiate the right-hand side. The derivative of 10 is 0. Step 3. Equate and solve. X dy dx plus y equals 0. We want dy dx. Subtract y from both sides. X dy dx equals negative y. Divide by x. Dy dx equals negative y over x. Answer, dy dx equals negative y over x. Remember, whenever you see x and y multiplied together, use the product rule. And whenever you differentiate y, attach dy dx. Now let us move to section 5. Higher derivatives. What are higher derivatives? When we differentiate a function, we get the first derivative. This is dy dx. It represents the gradient. If we differentiate the derivative, we get the second derivative. This is written as d squared y, dx squared. It represents the rate of change of the gradient. If we differentiate again, we get the third derivative. D cubed y, dx cubed. There is a physical meaning to this. If y represents displacement, position, the first derivative, dy dx, is velocity, how fast position changes. The second derivative, d squared y dx squared, is acceleration, how fast velocity changes. Let us look at example 7, finding higher derivatives. Given y equals 3x to the power of 4 minus 2x squared plus 5, find d squared y dx squared. Step 1, find first derivative, dy dx. 3x to the power of 4 becomes 12x cubed, minus 2x squared becomes minus 4x, plus 5 becomes 0. So dy dx equals 12x cubed minus 4x. Step 2, differentiate again. To find second derivative, d squared y dx squared. 12x cubed becomes 36x squared. Minus 4x becomes minus 4. So d squared y dx squared equals 36x squared minus 4. Answer, d squared y dx squared equals 36x squared minus 4. See? Just differentiate twice. Let us look at example 8, evaluating higher derivatives. If y equals sine of open bracket 2x close bracket, find the value of d squared y dx squared at x equals pi over 4. Step 1. First, derivative. Use the chain rule. Outside is sine, inside is 2x. Derivative of sine is cosine. Derivative of 2x is 2. So dy dx equals 2 cosine of open bracket 2x close bracket. Step 2. Second derivative. Differentiate 2 cosine of open bracket 2x close bracket. The 2 stays. Derivative of cosine is negative sine. Derivative of inside 2x is 2. So d squared y dx squared equals 2 times negative 2 sine of open bracket 2x close bracket, which is negative 4 sine of open bracket 2x close bracket. Step 3. Substitute x equals pi over 4. D squared y dx squared equals negative 4 sine of open bracket 2 times pi over 4 close bracket. 2 times pi over 4 is pi over 2. So we have negative 4 sine of pi over 2. Sine of pi over 2 is 1. So negative 4 times 1 is negative 4. Answer, negative 4. Remember to use radians for trig functions in calculus. Now, I want to warn you about common mistakes students make. Section 6, I want you to pay close attention here. These are the traps that catch students in exams. Mistake number 1, trig modes. Using degrees instead of radians in calculus. Correction, always use radians. If the question gives degrees, convert them first. Mistake number 2, cosine sine. Forgetting the negative sign when differentiating cosine x. Correction, cosine becomes negative sine. Write the minus sign big in your notes. Mistake number 3, chain rule. Differentiating the outside but forgetting to multiply by the derivative of the inside. Correction, outside times inside. Do not forget the inside part. Mistake number 4, implicit differentiation. Forgetting to attach dy dx to y terms. For example, writing 2y instead of 2y dy dx. Correction, every time you differentiate a y, write dy dx next to it. Mistake number 5, higher derivative notation. Writing d squared y dx squared as open bracket dy dx close bracket squared. They are not the same. Correction, d squared y dx squared means differentiate twice. Open bracket dy dx close bracket squared means square. The first derivative. Mistake number 6, product rule in implicit. Forgetting the product rule when differentiating terms like xy or x squared y. Correction. If x and y are multiplied, use the product rule. Now it is time for class evaluation. Section 7. I want you to pause the video and solve these in your notebook. Do not just watch, you must practice to learn. Question 1. Differentiate I equals cosine of open bracket 3x close bracket with respect to x. Question 2. Use the chain rule to find dy dx for y equals open bracket x squared plus 1 close bracket to the power of 5. Question 3. Find dy dx given x squared minus y squared equals 16. Question 4. If y equals x cubed, find d squared y dx squared. Question 5. Differentiate y equals tangent of open bracket 4x close bracket. Take your time. Write down your steps. Do not rush. I will wait for you. For your assignment, section 8. Please do these at home. Question 1. Differentiate y equals sine of squared x. Hint, use chain rule. Question 2. Find the gradient of the curve x squared plus y squared equals 10 at the point open bracket, 3 comma 1 close bracket. Question 3. Given y equals e to the power of 2x. Note, the derivative of e to the power of x is e to the power of x. Find d squared y dx squared. Question 4. Differentiate implicitly. X squared y plus xy squared equals 5. Question 5 is a challenge. If y equals cosine of open bracket x squared close bracket, find d squared y dx squared. This last one is tricky. It combines chain rule and higher derivatives. Do not worry if you find it hard. Just try your best. Let us do a summary of what we learned today. Section 9. We learned about trig derivatives. Sine becomes cosine. Cosine becomes negative sine. Tangent becomes secant squared. We learned about the chain rule. dy dx equals dy du times du dx, outside times inside. We learned about implicit differentiation. Differentiate course terms normally, but multiply by dy dx. We learned about higher derivatives. D squared y dx squared is the derivative of dy dx. It represents acceleration in motion problems. We learned about radians. They are essential for all trigonometric calculus. Here are some teacher's tips for WAEC. Transition to implicit differentiation is often difficult for students. Emphasize that y is a function of x, so the chain rule applies to it. When teaching higher derivatives, clarify the notation d squared y dx squared versus open bracket dy dx, close bracket squared explicitly on the board, as this is a common confusion point. For trig functions, constantly remind students to check their calculator mode and always write down every step. Do not skip steps in implicit differentiation. I know this was a long lesson, but you have done amazingly well. Calculus can be confusing because of the many rules, but you now have the tools to handle them. Remember, practice is the key. The more you practice differentiating functions and applying the chain rule, the faster you will become. If you enjoyed this video, please give it a like. It helps the channel grow. If you have not subscribed yet, please subscribe and turn on notifications. I post new lessons regularly. If you have any questions about this lesson, or if there's a specific problem you're stuck on, please comment down below. I try to answer as many as I can. And remember, for personal questions, my WhatsApp line is in the description box below. Do not hesitate to reach out. Thank you for watching. Keep practicing, stay confident, and I will see you in the next lesson. Goodbye for now.